Hello, grade 8 learners. I am teacher Nur-aine and welcome to our math class today. Our lesson might sound a bit mysterious at first, but I promise it's fun and surprising. So our topic is representing integers as sums of two squares. This simply means writing a number by adding the square of one whole number and the square of another whole number. So today, we will explore how this works, why it matters, and how we can create our own examples. By the end of this lesson, you should be able to first explain what it means to represent an integer as a sum of two squares. Second, appreciate how patterns in numbers can make math interesting and enjoyable. And lastly, construct your own examples of integers written as sums of two squares. So let's begin. Before we formally start with our discussion, let me ask you something simple. Have you ever tried arranging objects like beads, tiles, or candies into square shapes? Yes? Yes. When you make a square arrangement, you are actually forming a square number like 4, 9, 16, 25, and so on. Now, imagine combining two different square arrangements and putting them together. When you add them, the result is what we call a sum of two squares. This means today's lesson is simply about combining two square patterns to form a new number. It's visual, relatable, and something you've actually done before just without noticing. So let's refresh our minds about squares. A number squared means multiplying the number by itself. So like for example, 6 squared is equal to 36 because 6 times 6 is 36. So yeah. 7 squared is equal to 49 because 7 multiplied by itself, which is 7, is 49. 11 squared is 121. So this will help us build sums of two squares later. So what is a sum of two squares? A number is a sum of two squares if it can be written like this. N is equal to a squared plus b squared. So let's have another example. 10 is equal to 1 squared plus 3 squared. 1 squared is 1 and the square of 3 is 9. So 1 plus 9 is 10. 29 is equal to 2 squared plus 5 squared. 2 squared is 4 and 5 squared or 5 times 5 is 25. So 4 plus 25 is 29. Another is 50. So 50 is 5 squared plus 5 squared is 50. Why? Because 5 times 5 multiplied by itself is 25 and 5 squared plus 25, which is 25 plus 25, is 50. So yes, different combinations give us different results, and that's what makes this topic interesting. So why can some numbers be written this way? Some numbers can be formed by adding two squares and some cannot. There is no magic trick, just patterns. So yes, if you can find two whole numbers whose squares add up to the target number, then that number is a sum of two squares. Today, we will focus on creating examples that do work so you can practice analyzing number patterns and building your own. So we have here the first method, which is the trial and check. So let's try expressing 26 as a sum of two squares. So for the step 1, you need to list some squares smaller than 26, like 1, 4, 9, 16, and 25. So for the step 2, let's try combinations. 25 plus 1 is equal to 26. So yes, So we write 26 is equal to 5 squared plus the square of 1. So we already know that 5 squared is 25 and the square of 1 is simply 1. Yeah. And 25 plus 1 is 26. This is the simplest method, testing pairs until we find a match. So we have here another method, which is the use of Pythagorean triples. Do you remember Pythagorean triples? Yes, it is the numbers that satisfy a squared plus b squared equals c squared. For example, 3, 4, and 5. 3 times 3 is 9 and 4 times 4 is 16. So 9 plus 16 is 25 and 5 times 5 is 25. So yes. Another example is 8, 15, and 17. So this tells us that 17 squared is equal to 8 squared plus 15 squared. So 17 squared is 289 and 8 squared is 64 and the square of 15 is 225. So 64 plus 225 is equal to 289. Another example is 9, 40, and 41. So 41 squared is equal to 9 squared plus 40 squared. So 41 squared is 1681 and 9 squared is 81 and then the 40 squared is 1600 or 1600. So 81 plus 1600 is 1681. So yes. And also, the smaller numbers gives us sums of two squares. 17 is equal to 1 squared plus the square of 4. Because 4 squared is 16 and 1 squared is basically just 1. So 1 plus 16 is 17. This method helps us create examples using geometric patterns. So we have here the last example, which is the pattern building using tables. So let's look at a simple table of new values. We have here A, the row 1 is A, B for row 2, A squared, B squared, and A squared plus B squared. So we have here the 4 for A and 7 for B, A squared of 4. Square of 4 is 16 and the square of 7 is 49 and then 16 plus 49 is 65. So another example is 6 and 2. The square of 6 is 36 and the square of 2 is 4. So 36 plus 4 results to 40. So we have 9 and 1. So the square of 9 is 81 and the square of 1 is 1. So 81 plus 1 is 82. And then another is 3 and 8. So the square of 3 is 9 and the square of 8 is 64. So this results to 73. You can see that different pairs produce different results. By adjusting A and B, you can create unlimited sums of two squares. This is where number patterns become fun. So now let's move on to our activities. We have activity 1, which is the guided practice, and then activity 2, which is to create your own. So let's first start with activity 1. I want you to try representing these numbers as sums of two squares. We have here 3 items. I will give you 20 seconds per item. So yes, it's 20 plus 20 plus 20 is 60 seconds, which is 1 minute. I will wait for 1 minute starting now. 45 seconds. Thirty seconds. Ten, nine, eight, 7, 6, 5, 4, 3, 2, 1. Time's up. So uh, for 34 we have the square of 3 and the square of 5. The square of 3 is 9 and the square of 5 is 25. So 9 plus 25 is 34. So for 45, we have the square of 6 and then the square of 3. So 6 times 6 is 36 and 3 times 3 is 9. 36 plus 9 is 45. So for 58, we have 7 squared plus the square of 3. 7 times 7 is 49 and 3 times 3 is 9. So 49 plus 9 is 58. Have you got the correct answer? Yes, some of you got correct answers and others have not. They have not got the correct answers. But I hope you can do better next time. I know you can do better next time. So thank you. So for our activity number 2, which is create your own, I want you to choose any number from 30 to 100 and try to express it as sums of two squares. Example, let's try 74. Check 8 squared. 8 squared is 64. 74 minus 64 equals 10. So not a square. Try another 7 squared. So 49. Because 7 squared is 49. So 74 minus 49 is equal to 25. So yes, we can write 74 equals 7 squared plus 5 squared. Now, you try your own. So to summarize our discussion for today, a number is a sum of two squares if it can be written as n equals a squared plus b squared. We can find examples by trying combinations using Pythagorean triples, observing number patterns. And observing number patterns. So, and through these activities, you practice thinking, appreciating math, and creating examples on your own, which meets our goals for today. So for your final task before we end, please answer this. Write 97 as a sum of two squares. I will leave that as an assignment. So that's all for today. Thank you so much and have a blessed day. Bye!